this is Kavin. This is my deep learning ICP-6. So deep learning ICP-6 consists of 4 questions. The first one is to add one more hidden layer to the autoencoder, which plays the input and reconstructed representation. So for doing all the 4 questions, the basic setup of the programmers, the first step is to import libraries where NumPy is the fundamental package for scientific computing, Keras for the deep learning, and Matplot library for visualization. So NumPy is for scientific computing, and Kera is used for the TensorFlow deep learning parts and adding layers, etc. Matplotlib is to visualize the outputs in Python. So the second one is to import the dataset. We have used the Fashion MNS dataset, where Fashion MNS dataset consists of images of about 10,000 of training 60,000 examples and test set of 10,000 examples. So each data has 28 cross 28 gray image. Next one is to store the data set into xtrain and xtest. Next, coming to the data pre-processing, we divide by 255 for the normalize the data dimensions and reshape the data set. That's all pretty much about the data pre-processing. Next one is to do decoding and encoding and decoding. So in autoencoders, if we have an original input, we encode it compressed. While doing encoding, we'll get a compressed representation, and again, if we decode it, we'll reconstruct the input. So this is about the encoding part, and this is the decoding part. In encoding, we give 8 cross encoding dimension using activation ReLU as the activation layer. So to create an autoencoder, we'll give the decoded input image and the decoded image, and create the autoencoder model and fit the xtrain on the autoencoder data on the MNS dataset for 10 epochs and batch size of 128. Next, predict the test data and plot the test data. So coming here, if you see here, we could say what's a summary about the model. We have one input layer and 4 dense layers, adding four layers. So running on 10 epochs. So now it has run for 10 epochs. Now if you see, the first one is to see the test image, the original image, and this is our the predicted image, which is much more similar. Now we could see what's the difference we will get in the output when we add the noise factor, introducing noise here. Now same thing with the noise. We could see this is the test image, and this is our predicted image. So we could see now what's the we have plotted all the images, and here we could see what's the accuracy of the last epoch happened. So we got about accuracy of 49%. Not much about it. Thank you.